Hi guys, so this is a brief note about what exactly I want you to include in the report so that you can really shine and I can give you full credit without any doubt. So first of all, in the observations you should include the column of the delta t's, which are the time intervals um, for your ruler. Um, Next thing to do is in either the calculation section or still observation. It depends. It's up to you. I mean, do what you think is better. You will have to include 3 tables, and each table is associated to a plot. So you have the tables. I'm sure about that because I checked. I think everybody. So this table should be the table of time, distance versus time. This is velocity versus time. This is acceleration versus time. And so you should have those data, and you should plot them, all of them. But remember, when you plot something, you usually need to include error bars, and I want you to include error bars here. Now, you can feel lost because you didn't really write down any error bar, any error for x's, v's, and a's. But actually, the way to calculate that is very simple. Now, the reason is that the only error we had in that experience was the error for d, for the spacing of the ruler. The error which we call delta d, right? Now, the way you calculate, for example, the error for the first entry of the x graph is just propagation of error, an easy, very easy one. Just take, so the error on x is given by, on x1 is given by x1 times this ratio, delta d over d. Same for x2. The error on x2, the second entry, is x2 times delta d over d. Same thing for v. Error on v1 is given by v1 times delta d over d again. Error on v2 is given by v2 times delta d over d. Error on a1 is given by a1 times delta d over d, a2 delta d over d, and so on and so forth. Okay, so it's very, very easy. The point is that these quantities are calculated starting from d. So basically, it's the error on d that determines the error on them. It's propagation of error again. Okay, now be careful. Like the plot for distance is, you don't need to do anything with that. Just plot it and see what happens. You should see a parabola, right? The plot for velocity is the most relevant one because that one should be a straight line with an intercept different from 0, which is v0, but we are not very interested in that. But the slope of the graph should be g, right? So if you fit the graph with a straight line, you should find g. Be careful. You do have an intercept here, so you shouldn't check the box that says check this box if you want your fit to go through the origin, 0, 0. In this case, your line doesn't have to go through the origin, because there is an intercept different from 0. Good, so you can find g and the error on g, the fitting tool gives you the error on g too. So you have g and error on g. Be careful, format the number accordingly to the rule. Keep 2 sig figs for the error, and then keep the same number of decimal places for the value of g. Then go to a. Here you should, theoretically you should see something constant. You're not going to see that. You're going to see something like scattered points. Now, I don't really care. The point is that you can still use those data, the data for a, taking the average and then the standard deviation, so that you get an estimate for g, because the acceleration should be g, right? So using that this very easy calculation, which many of you have already done in class, you can get another estimate for g. So all in all, you'll have one estimate for g coming from the velocity, one velocity graph fitting, and the other coming from the acceleration table, just by using average and standard deviation. So you should compare the two methods and tell me which one was the more accurate, meaning which one had the smaller relative error where by a relative error I mean take the ratio between delta G in this case and G, delta G in this case and G, and see which one is the smaller. So that method will be the more accurate. But still, remember, you need to compare your two results with 9.1, which is the accepted value. You will maybe see that one of the two is compatible, is consistent with G, with 9.1 I mean, and the other is not. That is very interesting and very actually standard, something that it actually occurs. So it's interesting to see. The last thing I want you to do is explain with your words why the column delta t is different from the other t columns here, so the values here are different from the one here, and why these columns here, even though they are supposed to describe the same kind of thing, which is time, the absolute cumulative time, they are actually different. We discussed that. It had to do with the fact that you're taking the midpoints of the time interval and so on. Good. I think it's pretty much it, and okay, yes, so just do that and you'll do very, very well. Okay, good luck.